At around the 20-minute mark, the presenter demonstrates code that transfers data files from the S3 workbench to a Databricks file system, DBFS location. However, this method is not recommended for files containing protected data because DBFS files are accessible to all users within our systems. The preferred practice is to mount your S3 workbench to DBFS. This approach ensures that the content remains accessible while still being protected by the security rules governing the group's S3 bucket. Please note that the notebooks available on the DataCamp materials page contain the correct code, not the code shown in the presenter's demo.
Welcome to session 5. At the end of the session, questions will be answered by our session speakers. I will say that some of our presenters have also been helping each other out and answering questions in the Zoom chat as they're being asked in the chat itself. So that may help Dan out as well today. And then this session does have a notebook available. Laura will be dropping it in the chat so you can access that during our demo. And then, so without further ado, we have R for SAS programmers with Dan Anderson. So I'm going to be passing things over to him now to give you more information about himself and his session.
Thank you, Julia. If you can stop sharing and then I'll share my screen. Oh, yeah, actually, you're right. No, you're right. Yeah. All right. I forgot. So my name is Danny Anderson. I've been in the field of biomedical research primarily for the past 15 years, at least. Anyway, and I started with R actually about 14 years ago. Although I transitioned quickly into SAS, I've been primarily SAS for the past 12 years, but off and on did R with my graduate trainings, as well as just periodically as it was a more appropriate platform to use. I've also been doing Python for, off and on for about 10 years. But also all kind of in the realm of functional programming, focusing on statistical analysis work. I would say my background is more in the realm of statistics and like experimental design and interpretation of statistics. And then, but obviously because of the interplay with computing and programming, I've definitely focused on programming a lot recently, including distributed computing work, cloud computing work, focusing on process efficiencies with larger data sets. So today's goals are, it's lofty for me to try to present everything about R in Databricks. And so really what I wanted to do is address some of the fundamentals and then give some examples with the understanding that realistically, I'm not going to be able to get into everything. We will discuss a little bit about what it means for distributed computing with R and how to use our the different packages and libraries. I'll talk about what data sources we can access, how the R tables are similar and or different to the SAS tables, as well as the Spark tables. I will be discussing I'll show a couple examples of graphical outputs, and then of course our output data locations. Was that the only slide I had? Yeah, okay. So next I'll go ahead and go over to my notebook. Perfect. Let me try to move all that. All right. So as you know, the title of this talk is discussed. It's more about R for SAS programmers. I've kind of designed this as a quick start guide for using Databricks notebooks with the R compute clusters. In the presentation, you can expect a quick discussion of what I would expect about R for this. Also about how the different ways that we can implement distributed computing with R on Databricks, data files, how they're managed and where they can be. And then hopefully that will only take 5 to 10 minutes, and it'll give me about 10 to 15 to focus on some examples of how to do this work. And then I'll have some extra resources at the end, just some hyperlinks and things like that. The expectation, again, is that this is a 45-minute conversation. There's only so much I can really address. So I do expect to be hit up with a bunch of Q&As that I'll answer, probably tonight, and we'll get those back to you. Also, we understand that not everybody is about R, and so we will, like everything else, we've got some upcoming office hours or seminars sessions about Databricks in general, and R will be included in some of those examples, including and likely have R specific sessions depending upon demand and specific interests. So let me dive into this. But I did want to give the caveat that don't expect me to be able to explain everything about R and Databricks in the short time that we have. I know that Derek did a pretty decent description of when to use R versus Python. And what I really wanted to call out here is just that, like we've discussed, R is an open language, statistical computing and graphics project. It was actually based off of the S language and environment that was used by Bell, and has really been focused towards statisticians. So, although, and I think that for me, the thing I really appreciate about R is that it provides a wide variety of statistical and analytics tools. And rather than just giving you point estimates, they're clear on giving you your ranges. And basically, as a statistician, you can look at all the secondary statistics that are necessary to be able to determine whether or not this was the appropriate model to be run, and whether or not your confidence on your outputs. I feel like Python specifically is generally written by a lot of computer science people. And so they're great at writing that out, but they tend to do more point estimates and just kind of give you a solid output and saying this is what the answer is, and not necessarily giving you the rest of the information that you need. Not to say that those packages don't exist, they're just not as prevalent. Although I will say the drawback is R there's not as large of an audience for R. And so you don't tend to have as many of those computer science people within the R environment that can actually build out really nice packages. So the number of packages is smaller, particularly when you're talking about R packages that are available and really leverage distributed computing the way we're trying to use it. So the functionality of R, we have a base packages, and then we can extend it with additional packages. If you were to run install.packages on your R cluster, I'll call this out. So you'll see I'm actually using an R specific, R only cluster. Because of the way that R is currently deployed, R does not interact directly with the CDR. You can use another environment to transfer CDR stuff into like a workbench area where you could then access it from R. But everything right now for R is pretty much everything has to be in your workbench space. But your functionalities can be extended by using these packages. You'll see, if I run install.packages, it shows what's currently installed, but it runs out after like G. Runs out of space. So another way is if you know of a package that you want, you can just check to see where the system file is. If it returns an empty string, then it means that it doesn't exist in our environment currently. And so you can run the install.packages with the package name, particularly if it's within this CRAN listing of packages. The other thing I did want to call out is that the basic data structure for data in R is a data dot frame, not to be confused with a data frame that you'll be working with in Spark. but it's called data.frame. Other packages and extensions include adding it out, extending it to like a data.table. There's tibbles, and I used to use it a lot for linear algebra because it does matrix calculations as opposed to a lot of other things that just kind of do a series of arrays. So when we're doing distributed computing for R, there's some documentation here. There's Databricks documentation for Spark R. And then within that, you'll see some stuff, additional extensions of work with Spark R or R and Sparkly R. The other thing I've documented here is the Apache Software Foundation documentation for Spark R. So basically, if you look at distributed computing for R, you have two primary libraries. One is Spark R, and the other is Sparkly R. And sometimes you'll wonder, well, what's the difference? The main difference is that Spark R is going to be more pared down, but it is the package that is, it's the API that is specifically developed by the Apache Software Foundation group. The same people who maintain Spark create this Spark R. It doesn't necessarily have, like I said, it's a bit more pared down, but it will implement the latest offerings as Spark, the Spark data frame changes. And it follows closely the Scala classing as well. So if you want to use Spark R, really you just have to you have to call the library into your space. And honestly, you don't even need to call it. You could use the Spark R double colon if you're concerned about your namespace. But normally you'll just load it all into your space here. Sparkly R, it was originally created by the group that did RStudio. It was a much more user-friendly environment that then was donated to the Linux Foundation. It's tightly integrated with the tidyverse. And tidyverse has like dipLayer and several other packages, including like, I believe RShiny is by the tidyverse group too. I've left the links here so you could research those on your own and look at the documentation of those things as well. When you use Sparkly R, you're going to need to call the library. Though, since it's meant to be integrated with the tidyverse, you'll probably want to load in some of those tidyverse packages at the same time. So like library and dipLayer as well. And then you'll actually have to create like a Spark connection, which is called, here it's SC Spark Connect with the method equals Databricks. This is a slight detour, but it's important, particularly since there isn't direct access to the CDR. All of your work for the time being is going to have to be, the data are going to have to be in your workbench. So a quite common question we're getting is, well, how do I access stuff in my workbench? Well, this is how you're going to do it. Ultimately, your workbench is an S3 path. It's an S3 location. And so you can use Unified File Manager to upload data directly to your workbench. You would have to put in a ticket with ServiceNow and get the UFM people to create a network drive that is going to connect you to, that's going to be a connection for you to upload documents from your local environment into your workbench. If you haven't already done this, haven't requested this before, you'll need to provide the exact S3 path to your workbench. And if you don't know where that is, you can pick any of your file names and just do like within SAS-Via, run the S3 location macro. And that will give you the S3 path that you need to provide to ServiceNow and Unified File Management Group so that they can create your network drive. I'm just going to quickly I have some images here so you can see, like when I log into my IDM, right, here's my app of, I don't know why it's called UFM, but it's the Go Anywhere app. If you click on that, it will if you have network drives within your home folder, you'll see a network shares, and it will take you down into like your workbench. And then within your workbench, you should have permissions to create folders. You can create your own personal subfolder or whatever you need to be doing in that area. So in this case, I've created a location in my workbench called R training content. I can run just a file service of the listing for my workbench to confirm that I have content within there. So you'll see here, I've got a couple screenshots that I used for populating this, and then I've got a couple data sets that I'm going to be using later on. This is also the way that data will be, like if you have reports that you need to extract, your reports will be sent through your workbench, and then also again through unified file management. One thing I wanted to point out is that, so these are for external files. You can run your listings and like your S3 paths. You can also mount these. That's another conversation. I just felt like it was more simple to just show it this way. I've never really needed it. But again, there's always alternative ways of doing things. This is just one that does work. Then on your local compute clusters, so if you think about it, your Databricks, your S3 is external to your compute resource. The compute resource has a driver node, and then it has its worker nodes. The worker nodes can be expanded and like spun up and spun down based upon the amount of work that needs to be done. But your driver node is going to be your primary node. For you to be able to do work with this data, so I'm going to work with, in my example, I'm going to be working with this laptop data CSV and the laptop data Excel file. For me to be able to do that, I need to bring it into my compute cluster. To do that, I would, there's a DBFS, and there's also just a file option. I will show some more information about that as you go through here. But so you'll see one that's files, and it's got the TMP always exists. So rather than looking at what my working directory is, which could be changing periodically, I'd rather just be able to create my code once and know that I can make a folder within this TMP, and that will be destroyed when we shut this down. So then I create these locations. I also notice that even though I've got TMP demo files, I've got it as a file location or a DBFS. These are actually two distinct systems. So DBFS is the database or Databricks file system. It's similar to the Hadoop file system with some expansions to it. But when you have data, most of your data or anything that's distributed, also like larger data sets, is pretty much going to want to go to your DBFS, though you can move things to your temp. So going into some examples, I want to talk about file imports. Importing the file, in this particular case, this is just a caveat, some pre-processing. I show you the laptop data that I downloaded. This is the source of it from Kaggle. It's originally as a CSV file, but because I wanted to provide a demonstration of Excel files, I modified the file to be saved as an XLSX. And then I uploaded both of them to my S3 workbench using Unified File Manager. Then I need to move those data files to my compute cluster. So you'll see I copied them. And I can do a copy from my S3 path to a DBFS or the file temp.demo files. I don't know if I showed this, but so temp exists already, but demo files doesn't. I did a dbutils or an FS. No, I did dbutils makedir to create this next path, this next directory. And you can actually see an example of that work all the way at the top. I can show you later. It's actually hidden in the right at the top of my presentation before even the title portion of it. Within a system file, in this particular case, I want to be able to read in these files, right? I'm going to read in a CSV file. I'm going to read in an Excel file. I need to verify that these packages already exist on my compute cluster. So I'm checking the system file for the package and the name. It actually will only show you, one of them, whatever was your later one, but I had confirmed both of these actually exist on here. I'm reading them into the namespace. Anytime you read these into the namespace, be careful. Just again, look at which functions are going to be masked. So basically, the base version of that function has been overwritten by a Spark R version of that function. You can call both if you use this parentheses path, colon nomenclature. So I'll start with an example of importing the data as the CSV data, because it's the easiest to do. In this particular case, I can do a read data frame. This is a Spark R. And a function, it is actually just a data frame function to begin with, and it will create your Spark data frame from the CSV. You clarify that it was a CSV, that it's got the headers, allowing it to infer, and then calling a separator. And then I do a show data frame. You see it's only showing me the top 20. One row is, or one column is, was just a count in here. So it can be dropped at any time, and you can modify these as you want. But this is already into a Spark data frame. If you wanted to load an Excel file for now, the only way that we can really do this, and again, this is a lot of our packages by themselves, they don't go directly to a distributed method. So we're going to load it into an R data.frame, and then we will migrate that R data.frame to a Spark data frame. So likewise, here's the path for the Excel file. I run this function of Excel sheets just to see if there are multiple sheets, because by default, it will just read the first sheet. If I want my data from a second sheet, then I'd have to add an additional parameter here. And then this is just the head. This is, you can see, because I'm using Sparkly R also on this one, you'll see that I've got this thing being read as a tibble. But this is how this is working. This Excel sheets function, this whole read Excel is part of the tidyverse. So that's why I'm actually going to be using it. It shows it as a tibble, which is usually a component of a dip layer package. Here I'm calling in the Sparkly R library directly, because now I'm going to try to convert these things from an R data frame to a Spark data frame in R. So I create my Spark connection, and then I run a copy to with my Spark connection, the data frame, the R data dot frame, and then the name that I want to do it. And I've got overwrite set here. When I output, you can see there's actually a difference. So here at the top, when I ran it created a local data dot frame, I got a tibble. And here, when I'm running the output from this Spark data frame, it shows that it is actually a Spark data frame. The next things I was going to show are just some straightforward data analysis work that can be done in R. So there are a lot of built-in data frames. And rather than overcomplicate the amount of work that I was going to be doing here, I just went with some simple examples where here we're taking the very common iris data set, but we're running this similar to that copy two. There's also an SDF copy two that takes a standard data frame and runs it over into the iris data frame. In this case, when I look at the output of the iris data frame, it's a Spark data frame. I can do an SDF collect, which is again a Sparkly R command for basically the same thing as a collect command, but it has multiple ways of being able to collect in your data based upon different efficiencies and memory allocations that you want to use. You'll see that now it's being illustrated as a Tibble again, so it's no longer a Spark data frame that my output from here. So I'm going to use DipLayer for demonstration of a couple of additional data cleaning and grouping functions. DipLayer allows this extension, kind of like a piping of processes. So here I'm calling the iris data frame, which was created above. It's actually the Spark data frame for the iris data, running a group by, some summary statistics on it for my quantiles, and then storing it as a new data frame. Again, one of the main reasons for creating this as a new data frame, of course, is because I'm threading everything on here, and it's going to be it's summary statistics. So when I run collect on it, again, I get a Tibble, but the quantile DF was actually a Spark data frame. So you can see there's interchangeable components here. Collect would be part of Spark R and even Sparkly R to a degree, but then Sparkly R also gives that one of SDF collect, a Spark data frame collect, which either way, it's if it's not a huge data set, then it doesn't really matter which way you end up using it. Just for demonstration of adding, if I needed to create new data, a new column, I would use a mutate function here. Here I've created a new column called today that I'm just populating with the current timestamp function, though this could be any series of calculations that you may need to do. The mutate will allow you to create your new columns. And then I just output this into a new data frame, this with date. Again, actually, let me pause right there. Yeah, so I'm running, when I run the collect on this to look at my output, I'm seeing, everything as a Tibble. Now, what if my data set's too large and I don't want to do a collect on the whole thing? There are options with like Spark R. You can use the, I think there's a take 10. Also, you can just output the data frame itself. Like if you wanted to print the data frame itself, and it would just show you the top 20. Also, for example, if I want to collect something and I only care about a few of these things, I can create a list. In R, you create your lists as like a column, and basically it's creating a list. Like, for example, I just pick randomly petal width, species, and today. And that's pretty much all there was to do with that. I did want to demonstrate that you can do some plotting in data plots in R. So one of the libraries is called ggplot2. This is an expansion of ggplot, and it's a part of the tidyverse as well. They have a built-in data set called diamonds, and you could, this is just an example of what you can create as a data visualizations with the aesthetics of printing carrots versus price and having your color as a grouping for color for another level there. The ggplot by itself also has, like this standard cars data set that we're probably all very familiar with. And you can plot it with, miles per gallon by display display by highway, and you have your miles per gallon and classes in here. Additional resources, because I want to leave a bit of time, I just wanted to show you a lot of this is going to be within Databricks documentation. There's actually some good documentation on Spark R versus Sparkly R with some additional examples on how to work within the data frames. You can bring in, although we brought in CSV files and Excel files, you can bring in a JSON file, you can bring in all sorts of different files, and the documentation is all there, as well as several examples for running linear modeling and even some machine learning options in there. So I would recommend that everybody peruse those if you're interested in using the R, and specifically if you're looking at Spark R. And then, of course, the Apache Software Foundation documents for Spark R because that's what they support specifically. One thing I did want to call also is if you run this function data.package data, and it will show you all the available data packages that you can practice with that are built in based on different libraries that currently exist in our clusters. And so these are all different data sets that you can work with if you need some sort of example. And then they will all be part of this is part of the Lattice package. So if you look up documentation on Lattice, it will probably have additional stuff in there too. Details on how to use it. I am going to stop at this point because I know you guys have had a long day, and I feel like if I gave you much more, we would probably be saturated. I think that I've got about 9 minutes for questions that I can take from the group.
Yeah, so Dan, actually most of our questions have been answered by Aaron and Derek. But
awesome.
We did have a couple come in recently. They haven't gone to yet. So the first is, do Spark R or Sparkly R? This is where I'm not technical, but making sure I'm reading all of these things correctly. Do Spark R or Sparkly R support data table?
Yeah, data.table is the base structure, or it is part of the base. Like it's pretty much in the base. So data.table exists there, but again, all of your distributed computing work has to be converted into a Spark data frame. So if it was a data table, you're going to have to convert it into a data frame for any of the distributed work to actually work for you. Again, I think one of the struggles that you're going to find with Spark or with R in Databricks at this time is that your driver node is, I forget how large it is. I want to say it was like maybe 32 gig. It's not huge. Yeah, 32 gig on the driver. And so when you have like a single data set, like a single table, those would be all, if it can't be distributed, it has to be on the driver. It's only when you can distribute it out amongst the worker nodes that you're going to see Spark like really do its thing. And so again, you end up working with a lot with Spark R or Sparkly R and focusing on functions that have been built out to really leverage the distributed computing and distributed processing. But most of the packages that you're going to find for R are going to be designed for like local file and a single table. And so you're not going to see you may run into memory issues based on the size of your driver and the size of your data set, but B, you're just not going to see like the benefits of Spark. Like, one of the biggest benefits, in my opinion, of Spark is lazy execution. Which, if you haven't had a chance to look into that, because basically all it does is it looks at what you need at the end versus what you have at the beginning, and it says, well, if you're never going to need subsets of that, then it's not going to process it. So, that's a big part of it. And then also, some functions are really good at doing as a distributed function, but others require that it all be in, like, it just can't fundamentally, like, the calculations can't be distributed like that. So those are things that you're going to have to look at based on the particular packages that you're using. Having said that, eventually, I'm sure it's on the roadmap if it's not already there. The Spark R does permit for user-defined functions that you could then create. You could create your own custom functions that would be allowed to be distributed. Although I'm sure Aaron's killing me, like, biting his tongue right now, because I don't think that component has been built out yet on this or implemented yet on the Databricks platform for R.
Coming soon.
Yeah.
Okay, I think we have time for one more question. This one is referring to Colton's presentation, but Dan, I don't know if you could take it or if Colton wants to chime in. But it says, does the SAS 7 BDAT package have a size limit? Will it work like the right underscore large macro? I'm sure I butchered that.
Fortunately, Colton has come off mute. I'm hoping he can answer that because I haven't worked with that package yet.
I don't know the size limit, but since it's bringing into a pandas data frame, probably the big SAS 7BDAT files probably don't work all that well. We'll have to look probably further into that.
Okay. I think all of our other questions have been answered at this point, and we're like almost out of time, so it worked out fortuitously. So let me screen share just to wrap up and go over our agenda for tomorrow.
Yep.
Okay. And then a reminder, all of our questions, I know I've referenced this in other sessions, but as people are coming in and out today because of other meetings or commitments, all of our Q&A will be published on our Confluence space after our data camp wraps as an event. It will take us a few days just to make sure that we're tracking down all of our presenters and getting all of our questions answered, but then that will be available. We'll be sure to send out a communication when our resources are available. We'll also be uploading slide decks and presentation recordings and any other helpful resources that were shared out. So just wrapping up today and looking at tomorrow, first, huge thank you to Dan for presenting and all of our other presenters today. They were great sessions. We had really great attendance numbers. So looking forward to tomorrow. So we'll kick things off with CCSQ QuickSight Data Visualization with Sarah Davis. That's going to be from 1 to 2 p.m. Eastern Time. So same start time and end time as today. So our second session is going to be qualitative analytics capabilities using NLP with Nikhil. Our third session will be a day in the life of a plane with Gennady Sherman. And then our fourth and final session will be wrapping up, as we mentioned this morning, with CCSQ DNA Roadmap and Vision with Ken Howard, Alicia Hudson, and Justino Sardin from 4 to 5 p.m. Eastern Time. So we look forward to seeing you tomorrow. And thank you everyone so much for attending. And 1 p.m. tomorrow, we'll be logged on reading. Have a great night.